like to explain the last topic of first unit for the subject microprocessor and microcontrollers. So this is the remaining syllabus, simple program involving logical branch and call instructions, sorting, string manipulations. So before going to the theoretical explanation, first I want to show you a practical exposure video on this programming, how assembly level language programming can be executed. So this is the index I am going to explain in this presentation. All of you go through this video presentation, how I am going to subtract two numbers. See here, I have already this is the environment of Mazam software. So here we have file menu, edit menu, search menu, view menu, options menu and help menu. Here I have already done the additional program. Now I am going to show you how to subtract two numbers. So this is called the editor window. So in this editor window I am editing. You can see here I have removed add and I have typed here subtract. Okay, and I want to subtract two numbers 4 and 7. Okay, so here it will subtract the uh, so subtraction. So I am changing it to subtraction. See here I have taken a, here a and a. So a is equal to 4 and here I have taken b variable, b equal to 7. Okay, so now subtracting BL and BL because A is loaded into BL register and B is loaded into DL register. Now I am subtracting the two registers DL and BL and the result will be stored. Now see here how to subtract the values. So first here we have to perform for errors. So this is giving the no errors, that is the Mazam adds.asm, that I'll show you all these things. Next, link space add.obj, it will create object files. So and those object files will be linked. So that is what we call linking. So to execute, so here we have to give the file name.exe and here you can see that 3. There is the output. Okay, on left side you see here. So and these are the sum of the instruction to print the string, to print the characters. These are all internally taken by the DOS instructions that we will see later. So here for every program we have to write an ALP to add two 16-bit numbers using direct address mode, or write an ALP to subtract two 16-bit numbers. Like that we have to write an aim. So for every experiment we have to write and we should know what is aim of this program. Okay, so that is what you call the aim. And this program will be written in terms of ALP language. ALP stands for Assembly Level Language Programming. Okay, and the tool I am going to use is called Mazam tool. Mazam stands for Microsoft Macro Assembler. So this is the full form of the Mazam, and this is the tool to execute. Okay. For example, VHDL, Verilog, these are the hardware design languages, and those hardware design languages will be run on Xilinx tool, Model Sync tool, like that. We have so many types of tools. So here also assembly level language can be run on different tools that I'll show you. So one of the very well-known tool is MASM tool. So these are the advantage of assembly level language. It is almost impossible to write the programs in machine level language. So that's why here we have taken a human readable form of language, which is called as assembly level language program. Already I told you all these advantages and all the previous presentations. So it is human readable form. It uses symbolic characters or words or object address representation. It occupies very less memory. These are some of the advantages of assembly levels. What is the need of any software language? Any software language required to communicate between human beings or to hardware units or to computers? We need definitely language. So what are the applications of this ALP language? I told you this ALP language is mainly used for real-time applications. Real-time means the task required by the application must be completed before any other input to the program that will alter its operation can occur. So it will be run within time specified. That is what we call the real time. So such applications can be run by using this ALP programming. That's why still it is existing in the field of electronics. Okay. So this is the our MPMC lab syllabus. Right. So part one we are having ALP programming using 8086 microprocessor, and part two is interfacing of different units, and part three is ALP programming using microcontroller using Kill Micro software tool. Okay. And here what do we need to do a lab? Okay, what do we require? We require tools, different tools, and ALP language. ALP language means here the combination of assembler directives, addressing modes, instruction set, data types, syntax of the program, and a different register set. So we should have the knowledge of these 6 types of parameters to construct a language, ALP language. And to execute this language-based programming, we need different tools. So first we will see what are different types of tools here. So this is what is software and all. Okay. So there are we need 4 types of tools here. One is called as editor tool, second one is assembler tool, and third one is linker tool, and the fourth one is code view or debug tool. So these are the 4 tools required to execute a program. Okay, what is editor tool? Everywhere you know that editor means editing the program or editing some document is called editor tool, right? So here we can use MASM editor directly, the MASM tool itself, or else we can write the program in the notepad, and that file can be saved as filename.asm, and that file can be open in MASM software. Okay, that is what we call the editor tool. Right, see here editor tool is nothing but to create source file. Okay, every program is having its own source file. C language also having source file .c. Right, VHTL program .vht. These are all called as source files. MS Word, MS Office we are having .excel, right? .word, different types of .doc is called Word file. So they are all called source files, and here also we have to create one source file, and to those two source files maybe use Notepad or any other editor tools to create the programming, and those tools must satisfy the ASCII text file formats, and here and those files will use .asm to save the files. That is called editor tool. And this is assembler tool. So assembler tool means what is assembler? To convert assembly level language to machine language is called as assembler. And here we have different types of tools: MASM, ASM, NASM, and GNU. Okay, these are different types of tools we are having in the industry. And a very well popular one is MASM tool. Turbo assembler is called TASM. And this TASM also some different colleges are they are using, and different companies they are using for programming. And what this assembler will do, this assembler not only convert high level assembly level language program to machine language, it also do some operations. The offset displacement of named data types, set of labels. The assembler generates 2 files on the hard disk, The first file is called as object file, and second file is called as the assembler list file is given as extension of LSD. So these are the different jobs done by the assembler. And linker tool, this is also very important tool. So a linker is a program used to join several object files into one large object file. Means when you are writing the program, every line of the program will be executed as a separate object file. At the time of execution, we need to link up all these files. So that's why here we need linker tool. The linker produces a link file which contains the binary codes for all the combined modules. Okay, so that is the advantage of this linker tool. Okay, so this is one execution stage, the last stage, because one instruction fetching, decoding, and execution stage is there. So that is what we call the execution. And the execution done here by two ways. One is the CV code view, and another one is called as the debug tool. A debugger is a program that allows you to trace the execution of your program and examine the content of registers and memory. Okay, so that is what we call debugger. And in simply, if I say that debugger is a execution tool to execute the program, and code view also one of the tool to execute the program. But here for 16-bit programs, Amazon supplies a 16-bit debugger named code view here, and code view can use to debug only 16-bit programs. So this is the drawback of the code view. That's why here we can debug using debug also. And how to enter into Amazon? So here we have given some commands. So go to run and type cmd. The run command is type cmd and then cd slash, right, cd space masm 611 slash cd binar edit file name dot asm. For example, here we have to give edit add dot asm. Okay, then you can enter into the masm's environment. Then type the program and save the file and program for every line, not every line, every line. Then how to edit and how to suppose. Then first after entering into the Mazum environment and after enter the program in the Mazum editor tool, then what we have to do, we have to verify for the errors. Then what we have to do, we have to type here Mazum space filename dot asm. So this is also one of the Mazum tool, right? Mazum space filename dot asm. So it checks for errors. If there is any error, it shows the errors. Next, then it will create some object files, and to store that object, to join that object files, here we are using linking. Okay, link filename dot opg. Yeah, right. After that, it will link and then press enter for 4 times, and then type cp space filename dot exe. Then click in the code segment, and then it shows two segment, data segment and code segment windows. Then click in the code segment and press F8 or F5 until int3 or int21 is reached. Then if necessary, do the changes in the data segment, otherwise execute the program simply. Okay, so different data types we need to write down the program. Already I told you, DB stands for define byte, DD stands for define double word, DW stands for define word. Right, means here we can define 4 bytes, here we can define 2 bytes, right, 8 bytes and 10 bytes. So different ways you can define the program. And these are some of the assembly directives: org, assume, length, offset. This also was explained. So these are all required to write down the program. So what is the instruction format? First we need label or address, right? That is the, for example, start in the program you can write start. Then we need opcode or mnemonics move. Then we need operands ax comma bx. And last one here I forgot. We need comments also, right? Comment lines always explain what is the operation of the current instruction. Okay, here operands means maybe register or maybe operand, that will be explained by the addressing modes. And here these are called instructions or type of instructions, and this is the label in the programming. I'll show you what is that. And here I need move h comma 4c and move l comma 0, move in21 to exit from the program. Okay, so what is in21h? Right, in21h is to stop the execution, and this is in21h is to move from massive environment to DOS environment to execute the program. Okay, these are different types of addressing modes. I want to show you some of the program based on this addressing modes. Okay, so this is the basic program in ALP. Right, I want to display welcome to MPMC lab. And then what is the program? So the programming we have to start always with assume DS state and CS code. This concept I was explaining assembly directives. Okay, what is this assume DS data and CS code? Assume means here it is assuming the assembler will assume that wherever I see DA, DAT and CODE is maybe DS means data segment and CS means code segment. DS means data segments I want to store the data, and code segment means I want to store the instructions of the programming. Okay, so then I have tried this first statement. Okay, then data segment, and here what is that I want to display? And I want display here message DB welcome to MPMC lab. Okay, so what all these things I'm going to show you in the next presentation. See, what is the first line? Assume DS data and CS code. So in this assembly language programming, there are different registers present for different purpose. So we have to assume data is the name given to the data segment register, and the COD is a name given to the code segment register. Right, like SS and E are also used in the same way as CS and DS. Okay, next line is data segment. So what is data segment? In this assembly level language programming, a single program is divided into 4 segments, which are data segment, code segment, stack segment, and the extra segment. So now from these, one is compulsory, that is code segment. If at all, you don't need variables for your program. At least we need code segment to write down the program, and without this remaining 3 segments also we can write the programming. So if you need variables, if you want to define the variables of data, and those variables must be defined in the data segments. If you need variables for your program, you need you will have 2 segments, code segment and data segment. So you have to use these two. Right. So what is next line? Message DB. Right. What is the data segment in the programming? Data segment is the starting point of the data segment in a program, and data is the name given to the segment, and segment is the keyword or directive for defining segments where we can declare our variables. Okay. For example, here you can see that message DB. Here message is the variable. DB is the data type. Welcome to MPMC lab. Why it is defined byte? Because you know that ASCII formats are always in the form of 8 bits. So 8 bits means byte. So that's why here we are taking DB. Define byte. Next, message DB. Message DB I have just now explained. Okay. Next line is data ends. Data ends is nothing but assembler directive to end the data segment. Okay, end point of the data segment is called ends. Next line is code segment. What is code segment? Code segment is the starting point of the code segment in a program, and code is the name given to the segment, and segment is the keyword or directive where we can write the program of coding of the program is called as code segment. So next line is start. Okay, see here next line is start. So what is next line start? Start is the label used to show the starting point of the code, which is written in the code segment, is used to define a label as in C programming. Okay, in C programming also we have the label concept, and here next line is move AX comma data and move DS comma AX. These two lines are common for every program in 8086 ALP based programming. We have to remember about these two, and we have to understand what is this. Okay, after assuming data and code segment, still it is compulsory to initialize data segment to TS register. Okay, so move is a keyword to move the segment second element into the first element. Here we have written the move, and but we cannot move data directly to DS due to move commands restriction. Move command is having some restriction. Hence, we move the data to AX and then from AX to DS. Yes, DS is the data segment. Okay, I could not send the data DATA to DS. So that's why what we're doing, we are sending DA data to AX. What is data? Data is a data segment name, and that AX value are goes to DS. Okay, that's why we are having this instruction. AX is the first and most important register in the AL unit, which is called as accumulator. And this part is also called initialization of data segment. This we have to remember. What is this statement? Move AX comma data and move DS comma AX is nothing but initialization of data segment. Okay, and it is important so that the data elements or variables in the data segment are made accessible. So whatever the elements we write in data segments, they are ready to accessible if you write these two statements in the programming. Move AX comma data, move DS comma AX. Okay, next line, LEA DX comma message. LEA stands for load effective address. Right, where this message is available? This message is available in data segment address. Okay, because data segment is also part of your memory. Okay, right. Used to store the data values. So that's why to call that memory, we are using this load effective address dx comma message. What is dx? Dx is a data register. AX is accumulator, BX is base register, CX is counter register, and EX is data register. So here I want to display some data. Welcome to MPMC lab. So that's why here we are taking LEA dx comma message. Okay, so then move h comma 9. What is move h comma 9? That I'll show you. Right, it works with the value of ah register. If the value of 9 or 9h or 9h, that means print the string values address which was loaded in dx register. Okay, move ah comma 9 means to print the string values, so that we can see in the I was shown in the PPT video presentation. Right. So next one is move h comma 4c and in21h. Use it to exit to DOS. Okay, this is used to exit and this is used to move to DOS from maximum environment. And last statement is code ends, means end of the code statement, code segment. Okay, and last line of the program is end start. So end start means start is the label which was the starting point of the code segment, and to end that start we have to write end start. And then if you execute by using that execution steps, then you will see the welcome to MPM's lab. Okay, here I want to show you some of the programs based on different addressing modes. First I want to show you addition of two values. Okay, see, this is the addition table. Everybody must remember this addition table, how to add two numbers. Okay, so suppose I am taking two variables x and y, and if I add 0 plus 0, it is 0, 0 plus 1, it is 1, 1 plus 0 is 1, 1 plus 1 is 2, 1 plus f is 16, because it is 15 and plus 1. 16 equivalent in hexadecimal is 10. Like that, 2 plus 1 is 3, 2 plus 2 is 4. Like that, 2 plus f 15 plus 2 is 17, which is equivalent of 11h. So like that, this if you remember this table, and you can easily say that, and you can easily add any number. So for example, I want to add these numbers 1279h plus 4598h, then it is equal to 5811h. So how to add these values? Here I want to explain this small example. 6 plus 3, how much? It's a simple number, so I can say that it is equal to 9. Okay, 9. Next, a plus b. In hexadecimal, a means 10, b means 11, so total is 21. But here I have written as 5, and carry is carried as 1. Why it is 1 5? You go to this table a, and a is adding with b. See here, a is adding with b, so a is adding with b. So how much is the result? 1 5. 1 5 means it is not decimal 1 5, it is hexadecimal number 15, which means it is equal to 21. So decimal 21 is representation of 15H in hexadecimal. So that's why here I have taken as 5 here and carry as 1. So 1 plus 4 is 5. 4 plus 1 is 5 plus 1 is 6. So 6, 5, 9. So like that I can have the result. Okay, understood. So this is one more. Okay, how to add the values. This is equivalent of decimal, sorry, decimal. This is equivalent of hexadecimal. So like that, you can check this value also, how to add the numbers. So if the addition of two hexadecimal numbers is greater than 16, then subtract from 16 and write the value as a result and carry to the next stage. So here I want to write addition program using register addressing mode. So that's why register addressing mode means, right, I can write move bx comma ax or add x comma bx. If I write this like this type of instructions, that is what to call the register addressing mode. If the data is moving between two registers, if the operation is performed between two registers, is known as register addressing mode. Okay, see here I am explaining with two examples. Program to add two numbers, two 16-bit numbers. So one is without using move h comma 4c. Second one is moving using with move h comma 4c. So this we will see later. First you see here, alright, why it is called a register addressing mode. I have written here add x comma bx. Okay, so that's why it is called as register addressing mode. Okay, because I am performing addition programming between two registers AX and BX, but here what is AX is having? AX is having X1, because move AX comma X1 means X1 is called as source operand, AX is called as destination operand. So source operand will be moved into destination operand. So here also move BX comma X2. X3 is moved into BX. Okay, so that's why here, right, what is x1? X1 DW. DW is the defined data word. Okay, this is data type 0005, means 16-bit. X2 DW 0006. So I want to add these two values. That's why I'm defining it data segment, because these are the two data values. So that they are in data segment. So data segment and data ends. Here I have defined data values. So after that, after moving those values into x1 x and x2 into bx, then I can add. So to move from mass environment to DOS environment, to execute some commands, so I need this int21h. You see here, this program also having move x comma data and move ds comma ax. So to call x1 and x2, which were initialized in data segment, I need these two statements, move x comma data and move ds comma ax. Okay, so this is the program simply. You can see here what is move h comma 4c in 21h, and here with the move h comma 4ch. Okay, so before this into 21h, I written here move h comma 4ch. Okay, this program using offset result, and when I write this offset, yeah, load, it is like load effect to address that indicates address location. So that's why here, whenever the result is add x comma bx, means the addition operation performed between AX and BX, and result again stored in AX register, and that is moved into address location of SI. What is SI? The offset of data segment. Okay, that's why you can say the result in data segment at the time of execution. Okay, this is sum of n numbers. This is what we call the branch and loop instructions. So here you can see that loop instruction, and this is called loop. So when it is executing for number of times, that is what we call the branch and loop instruction. See here, this red color is the programming, and this is called label, and these are called mnemonics, and these are called operands, and these are called comment lines. So that's why here I have given the program like this. How to add sum of n numbers with less number of instructions. Okay, so here code segment and assume CS code. Here I am not taking any data segment, because here I want to execute using loop and control instruction. So here itself I can write the programming. Now move x comma 00. X comma 00 means x is loaded with 00. It is the first value. I want to add 0, 1, 2, 3, 4. Okay, 5 values 0, 1, 2, 3, 4. Okay, so move cx comma 05h. Okay, then cx is loaded with 05 means 5 values. Then it is initialized to 5. Okay, add ax comma cx. The content of ax is 0. The content of cx is 5. It will be added with ax. So the result is 0 plus 5. Next loop back. Again it goes back to back. And again it will be added with ax and cx. What is the result of this ax and this is wrong. It is like first it will take 0. It will be added with plus 5 and result is 5. And 5 will be added with 4 because the loop back means it will be reduced by one more value plus 3 plus 2 plus 1. Like that it will be loaded because here loop back means the statement is an unconditional unconditional branch and control transfer instruction. So what it does, it internally reduces the cx value by 1, right? Then cx becomes 4 here, so that's why here I have taken 4. So I added with 5 plus 4, then again it to go back to back. So what is back here? Right, add ax comma cx. So ax was already loaded with 9 and cx becomes 3. So like that it will be perform this operation of sum of n numbers. Subtraction, you know that subtraction is nothing but addition program only, because here subtraction will be done by using one's complementation, one's complement, two's complement subtraction. So this is the syntax of subtraction, like same as your addition. Okay, but here we have to remember in the place of borrow, here we have to see the carry and we have to take the borrow as carry only, and we have to, if there is a carry in the programming, then we have to verify the carry of the flag register. Okay, so these are sub cx comma bx means cx is subtracting bx and result stored in cx. Subtraction with borrow ch comma cl means ch is subtracting with val and result is stored in ch. Yes, and these are different types of subtraction methods. So you have to practice this one. And here I am going to explain one more addressing mode, immediate addressing mode. One more program using immediate addressing mode. What is immediate addressing mode? Immediate data is a part of instruction, appears in the form of successive bytes or byte. So move ax comma 0005. Right, this is the immediate value. So if you define this kind of instructions, so that is what we call the immediate addressing mode. Okay, see here I have taken SUB. SUB stands for subtraction x comma 2222. So this is a immediate number I want to subtract with the content of ax. What is the content of ax? The content of ax is coming from the address location of SI. Right. What is the address location of SI is having offset num1. What is offset num1? Offset is the assembly directive. Num1 is the variable. What is num1? Num1 is num1 dw5555h. Right. dw stands for define word. Right. What is this num1? Num1 is the variable as written in data segment. So you see the relation. SI is the offset value of data segment. So we are writing like this. How to call the data which is defined in data segment using SI, because physical address means segment address plus offset address. Segment address is always fixed. This physical address only, sorry, the physical address is only depending upon offset address. So the data segment can be combined with SI, BX or BI. So usually by default we are taking here always SI, which is called a source index. Now understood, for every program these two lines are common. Move AX comma data, move DS comma AX to initialize the data segment. After that we have to call the data to subtract the two values. So one data I have defined here and one more data I am taking the instruction itself as immediate address mode. Here you can see that if you write move AX comma 005, add AX comma 2387 like that. If the source operand is a number, immediate number, then it is called as immediate address mode. Okay. Now multiplication, you know that at the time of multiplication and division, we have to remember, and multiplication we have defined only source. By default, we have to will take the internally destination operand. Okay, so this is very important. And 8-bit to 8-bit multiplication or 16-bit to 16-bit multiplication or 8-bit to 16-bit multiplication, that we have to see very carefully. So this is the program. So multiplication program using, you see here, the multiplication program using indexed addressing mode. See, right, in this indexed addressing mode, if you write statement like this, move x comma si, then it is called as indexed addressing mode. So for this kind of programming, so what I am doing, I am taking this move x comma di, move cx comma bx plus si, and mul cx. So if you take the data values in the address location, the bracket indicates address location, right? This di is taken as move di comma 2000h. Here I don't have any data segment. So in the code segment itself, I can write the program and I can execute this program. Right? See how move si comma 1000h, move di comma 2000h, move bx comma 2000h. You can give some other value also. Move x comma di. See here, these are the values. These values become address, and this address of di means here we have to key the values in the address location of 2000 at the runtime. Okay, not in the data segment before execution. At runtime only we have to give the values, different values. And here you see move cx comma bx plus si, right? Bx plus si, and what is the meaning of this? Bx plus ci means here these two are having the brackets, and this form the address, right? So I can put some values in this address location bx plus si. Right. Now, what is difference between the previous programs and this program? Here, this program and this program is having predefined values, but here I don't have any predefined values. I can execute this kind of programs for for the user defined values at any point of time. So that is the difference between these two programs. This program is having predefined in the data segment, whereas this program is not having any predefined values. Okay, see here mul cx. Why don't you have any destination operand mul ax comma cx? Because the syntax of mul is mul source. Only here cx is the source value, and by default we will take the ax as the destination operand. So here multiplication takes place between ax and cx, and result stored in ax and dx register, because dx is called as data segment register. Data register. Dx is data register used to store overflow value and remainder values of division. Okay. And here division also 8-bit by 8-bit, or 16-bit by 8-bit, or 16-bit by 16-bit, or 32 by 16-bit. We have to carefully see, and we have to devise perform the division. You see here div num2. Okay, div num2 only source I have defined. And sorting, you know that what is sorting? Arranging of numbers either in lower order to higher order or higher order to lower order is called as sorting. So based on that, sorting is here two types: ascending order and descending order. If it is from lower order to higher order, ascending order. If it is from higher order to lower order, is called as descending order. Okay, so types of sorting is according to C language, we are having so many types. Some of the sorting programs are bubble sort, quicksort, and merge sort. And bubble sort is nothing but sometimes referred to as a sinking sort. Is a simple sorting algorithm that repeatedly steps through the list, compares adjacent elements, and swaps them. Right? This is very important. Values are swaps them if they are in the wrong order. Okay, that is what we call the bubble sort. And there are two more sorts: quick sort, merge sort, Like that, we're having so many types of sorting. Right. Sorting is based on these this syntax, comparison of the numbers. Right. If they are not satisfying the required sorting, then exchange of the numbers and then take the counter register, and this counter register will give the next value and go to the loop to execute or to verify one more sorting instruction. Okay. And here sorting will be done either 8-bit level or 16-bit level. What is compare statement will do? The compare statement in syntax is CMP destination comma source, right? According to our sorting, this comparison will be done and it will check for the condition. Okay, so that we will see, and that condition with the status of flag register. Right. Suppose if I have n values, if n equal to 6, then we have to verify n minus 1 passes or n minus 1 conditions or n minus 1 comparisons. Okay, see here 1, 2, 3, 4, 5, 6 values. Then I need 5 comparisons. Okay, so that is the main condition of the sorting. For example, you see here, I want to sort these values F9H, F2H, 39H, and 05H into ascending order. What is ascending order? Arrange the numbers from lower order to higher order. See, first you take the values as it is, right? Yeah, the values are F9, F2, 39, and 05. Next, compare F9 and F2. Right? F9 is larger than F2. Then right, they have to swap. So F2 comes here and F9 goes to this place. Then this F9 again compare with 39. Again F9 is greater than 39, so it's not satisfying. Then what is happening? 39 comes to here and F9 goes to here. Okay, so now F9 is compared with 05. Again F9 is the larger value and 05 is the smaller value. It will come to this position. Now this is the what we call the pass one, right? So this is called pass one. If I have 4 values, 3 passes. If I have 5 values, 4 passes, like that. Okay, then what is happening? F9 and F2 comparison. F9 and F2 comparison means what? Subtraction will take place between these two, right? When subtraction is taken these two, right? F9 is greater than F2 means no carry, right? If F2 and F9, right, here F2 and here F9, carry will be generated. Then it will check for the carry status and then mode swapping takes place or exchange takes place. That I'll explain in the programming. Next pass, you see I have taken F2, 39, 05 and F9. Now F2 is compared with 39, so F2 is greater than 39, so they are swapping 39 and F2, right? Again F2 is compared with 05, so F2 is greater than 05, so they are swapping. Again this F2 is compared with F9, so F9 is greater than F2, yes, so it will not change. Like that it will perform this operation and it will compare the values. Now you see here, now you see here, I have taken 39, 05, F2 and F9. Now compare 39 and 05, what happens? Right, 39 is greater than 05, right? So I'll get like this. Now 39 is greater than F2? No. F2 is greater than F9? No. So sorting has done. So this is what we call the ascending order. So how to write the program for this? Right. So this is the statement we are taking here. JC use it to jump if carry flag is equal to 1. Okay, we have to take this JC statement, jump to address location if carry flag is equal to 1. Okay, so this is the program. So this program is having an assume statement, data segment, and a code segment and code ends. Means code segment to code ends is the programming. The data segment data ends is the data defining. So string 1 is the variable, DB is the defined byte. Why it is defined byte? Because I have written sorting of 8-bit or byte values. Okay, so that's why here I have taken it as DB. So 99H, 12H, 56H, 45H, and 36H. I am taking with 5 values. So that's why here what's the value of CH I am loading with 0 4. 0 4 means 4 3 2 1 and 0. So 5 values are there. So then what is happening? Move AX comma data, move DX comma AX means initialization of data segment. Now move CH comma 04, right? Move CL comma 04, right? LEA SI comma string 1. What is LEA SI comma string 1? Load effective address of source index with string 1. What is string 1? As 99, 12H, 56H, 45H, 36H into the address location of SI. What is SI? SI is the offset address location of data segment. So you are loading offset address of data segment of the string values, so one by one. Now move one value into SI. Move SI of address location, and that address location value is moved into AL. Now move BL comma SI plus 1. That is first 99 is moved into AL and the 12H is moved into BL. Now compare AL comma BL. So when you compare, what is the statement JC down? Right? What is JC? Jump if carry. If you subtract two values, okay. If you subtract two values, what happens in the sorting? If you subtract two values, right? Then if 99H and 12H, if you subtract, what happens? 9 you can subtract with 2 and 9 you can subtract it with 1. Then you will get 87, right? Do you require any carry? Any carry generating? No. Then jump if carry down. If no carry, exchange, these instructions will be executed. Right? If carry is there, this instruction will be executed. Right? Now no carry. Then what happens? Move SI plus 1 to DL. Right? SI plus 1 goes to data register and data segment value again goes to SI. Now what happens? 12 goes to this location and 99 goes to this location. Okay, so that is what we call this SI plus 1. This is called SI plus 1 and this is called SI. Okay, now increment, after that increment SI. Now what is happening? Increment SI, it becomes SI plus 2. Okay, and decrement CL. What happens? This becomes 3. How many values? 1, 2, 3. Okay, next jump on no 0. So here CL value is 0. No, it will check for this one. This is also called conditional statement. J and Z. Okay, I am not given here. J and Z is nothing but jump on no 0, go to up 1. What is up 1? Right, move AL comma SI. Now what is SI? By incremented 56H. Okay, now move BL comma SI plus 1. Right, 99. Again 99 is compared with 56. Now again 99 and 56 can be compared, and if there is a carry, these instructions, if there is a carry, these instructions directly. If no carry, these instructions. Now again what happens? 56 goes to here and 99 goes to here. Okay, now what happens? 12, 56, 99, 45. Okay, this like this, all the statements will executed and the program will be sort the values in the ascending order, same as this statement. Okay, so here I have given how this takes place. This is sorting. So this is the programming using exchange instructions. You can use exchange instruction also to exchange the two numbers when it is performing the sorting operation. So these are some of the Viva questions. What is count? What is exchange? And yeah, any questions? Feel free to ask me. And thank you.